So hello everyone and welcome to the last and final week of GitHub in Focus. My name is Sean Kelly and I'm an application security expert here at GitHub and I'm your host for the week. I'm dialing in from Boston today, so tell me where you're from in the chat section. So in week one, we looked at all the ways GitHub is helping enterprises increase velocity by focusing on the developer experience. And last week was all about DevOps and what powers a successful DevOps program. Oh, I see a lot of places here. I see Boston, Georgia, Kansas, Wisconsin, Austin. That's awesome. So this week, we're talking all about security. As the rest of the world slowly adopts DevOps patterns, we continue to see that security is sent to the backlog and often forgotten. Well, not this week. This whole week, we'll be bringing security to the forefront of the conversation with insights from experts on the topic. So we'll talk about why DevSecOps matters for developers and why it's so crucial to keep the developer experience at the heart of security. You can see here that we've got an amazing week ahead of us. So today, we're kicking it off with our Enterprise Showcase. But before we kick things off, let's talk about a few housekeeping notes to make sure everyone has the best experience today. So if you have speakers today, please be sure to drop them in the chat tab. This is your chance to ask our product team any questions you want. For your optimal viewing experience, please make sure to join us from a desktop. We recommend using Chrome or Firefox, Safari. Other browsers will work, but we do recommend that you make sure that you're updated to the current version. If you want to book a meeting, because you're going to hear a lot of interesting things today. So if you want to have a one-on-one conversation with any of the experts on our team, please be sure to hit the book a meeting button on the top right-hand corner here. So let's get this show on the road. So today I'd love to introduce you to someone who is not only an expert in security, but also an expert cyclist who has over 30,000 kilometers of cycling under his belt. Yep, that's about 18,500 miles. And with that, I think he has about 10,000 kilometers more to be able to say he's completed a complete trip around the earth. So with that being said, I'd like for you guys to all meet Gray Baker. Gray is GitHub's Senior Director of Product Management for Security. Today, he'll be sharing his experience on the most common DevSecOps challenges our customers are facing today. Gray will also be discussing what a developer-first, community-driven approach to application security looks like. And if we're lucky, he might even tell us what made him want to cycle across the globe. So let's jump right into it. And folks, again, please, if you have any questions, please be sure to post them in the chat section. We'd love to hear them.
Hey, Sean.
Hey, Greg.
Wow, thank you so much for that intro. I have no idea where you dug out that old website of me cycling. I put that together, 5 years ago now? That was so that my family knew that I wasn't dead each day because they could see me still moving. It was a fantastic time. But I'm not here to talk to you about that today. Today, I'm here to talk to you about application security. And I'm really excited to do that because I've got a lot to share. Over the last 5 years, I've had the journey of going from being a developer myself to being a product manager in the security space. And so when I'm thinking about security, I'm always thinking about how we embed it deep in the developer workflow. And that's what I'm going to talk to you about today. So let me share my screen. As Sean said, I'm a Senior Director of Product Management here at GitHub. I'm responsible for all of the security products that we build, the products that we build to make it easy for you to write more secure code. I'd like to get to know you a little bit better before I start this talk. So I'm going to ask you, and I'm going to open up a poll for you to answer. I'd like to know what industry you're working in, and you should have that poll appearing on your screen right now. So what do people work on day to day? What industry are you involved in? And I know that security is critical across all of these industries. We've got some people from finance, got some people from healthcare, some folks working in government. A lot of you identifying as working in technology, manufacturing, retail, other, everything is covered. Security is important really across the board. So I'm not surprised to see so many of you coming from very different backgrounds to this talk. Okay. So today I'm going to talk to you about the state of application security, where we're at as an industry. Then I'm going to talk to you about the challenges to improving that state. And finally, I'm going to talk to you about what a true developer-first application security approach looks like. So let's start with the state of application security today. Where are we at as an industry? The first thing I want to say is that I think we all agree on where we're going. Almost everybody that I speak to in the security world wants to shift security left. They want to move the place that we're discovering security vulnerabilities out of being in the production environment, and definitely out of the case where a breach has been identified, and earlier into the development lifecycle, ideally catching those things as they're being developed, if not at build or test time. This is data from the Ponemon Institute. They compile a cost of data breach report every year, and this is from 2020. That's where the 3.9 million number, the average cost of a breach, comes from. But this idea of shifting security left, that's not new. I did some digging into where the numbers on this slide come from. Here's the earliest source that I found. This is from 2012. It's the IBM Security Systems team. This was a briefing that they had for their sales team. The numbers you can see here are exactly the same as the last slide, and the idea is exactly the same as the last slide. How do we shift security left? How do we move it away from finding vulnerabilities in production and towards finding them during development? We've been talking about shifting left for at least the last decade. I think if I trace this further, I could go even further back on these dates. How are we doing in that process? If we've been working on this for a decade, are we seeing progress yet? Well, when we look at the number of vulnerabilities that developers are introducing, it doesn't look like we are making progress. This is an analysis by the GitHub data team. They analyzed, using static analysis, commits of over 70 million lines of code to major open source projects. Think projects like the Linux kernel over a 5-year period. On every single commit, they looked at whether any new security threats were being introduced, or a very strong proxy for them, which is static analysis results in a security category. And they found that over that 5-year period, the relationship between lines of code written and security threats introduced didn't change. We're introducing security vulnerabilities at exactly the same rate in 2021 as we were in 2015. These two lines remain stubbornly correlated. And don't think that this is just open source. Don't forget that the largest contributor to open source on GitHub last year was Microsoft. The folks that are introducing those vulnerabilities by accident into open source are the same developers that are working on enterprise code bases day in, day out. We have no reason to believe that the number of vulnerabilities being introduced in private code bases is any way different to those being introduced here. And even if it was, we're all reliant on that open source code more and more. We all use open source in our applications. This graph is of the dependency alerts that GitHub sent across active projects over the last 2 years. We send a dependency alert when a vulnerability is discovered in an open source dependency, and we send those alerts to everyone that's using those dependencies. That's a really spiky profile to graph. Some of the spikes here will be vulnerabilities in very popular open source projects like Lodash or jQuery, Django, Rails, a number of others. When we find a vulnerability, or when the community finds a vulnerability in one of those projects, it triggers a lot of alerts all at once. But there's also a steady trickle day in, day out of vulnerabilities in the long tail of open source dependencies that we all use. When we add them up over the course of a year, in 2020, we saw 40% more alerts sent to active projects than in 2019. That's because we're all relying on open source more, and because the relationship between vulnerabilities being introduced and the lines of code written hasn't changed. Here's another metric on which we could be improving in terms of our security posture, but it doesn't look like we've made any difference over the last couple of years. Let's talk about credential leaks. This graph shows GitHub access tokens being accidentally committed to GitHub public repositories. Because we're GitHub, we can detect our access tokens perfectly. And if you accidentally leak one into a public repository, GitHub will automatically revoke it for you. Give it a try. If you don't believe me, it happens in less than a second. There really is no risk to leaking a GitHub access token on GitHub. But it's also a really good signal that if folks are accidentally leaking GitHub access tokens, they may be leaking all kinds of other secrets as well. And in fact, GitHub partners with a number of token issuers, folks like AWS, like Stripe, like Google, and like a long list of others, in order to automatically tell them as and when a credential is leaked so that they can respond to their customers immediately and remove any risk there. But the point is, we're still seeing these credentials leak into public code. We're almost certainly still seeing them leak into private code for exactly the same reason, where all of the access level that whoever had that token then gets escalated to anybody with read access to that repository. The rate of credential leaks is growing by 60% every year, according to this data. So it's no surprise when we look at the most common cause of breaches, using the data from Verizon in terms of their data breach investigation report, that in 2016, the most common cause was web application attacks. 2017, it's web application attacks again. 2018, you guessed it, web application attacks. 2019, web application attacks. And really, to labor the point, 2020, web application attacks. We haven't managed to shift security into the developer workflow. We haven't shifted it left. We are still seeing breaches as a result of it. Before I talk about why and the challenges to shifting security left, I want to ask you another question. I want to ask exactly what job function describes the work that you do best. Do you identify as a software developer, or are you on the application or product security team? Who is it that's dialed into this call? So please just take a moment to answer that poll. And I can see it looks like we're pretty balanced. It's almost 50-50 in terms of software developers and application or product security experts. Wow, yeah, that ratio is staying pretty stable. So about 50-50 between our developer population and the folks that are responsible for making sure that the code that we ship is secure. Though we're all responsible for making sure the code we ship is secure. I wish that the ratio you are seeing on your screens right now was anything like the ratio that we see in the industry as a whole. And I'm afraid that's one of the challenges that I'm about to come to. But everything I say here is also going to be super relevant to anybody that identifies as an engineer, because I passionately believe that the solution to application security is to move it into the developer workflow. Let's talk about those challenges. Why is it that we haven't shifted security left? Why is it that we're still seeing these breaches? Well, one of them is that security teams are hopelessly outnumbered. If we look at the industry populations across the entire world, we see a huge ratio between developers and security researchers, 570 to 1. Even when we look within the largest enterprises at the folks that they have on staff, we commonly see a ratio of 100 developers to 1 security researcher. We're hopelessly outnumbered in the security team. And it's not really surprising to therefore hear that IT security professionals in vast majority say that their team is understaffed. Unfortunately, we have a global shortage of cybersecurity skills. 70% of Security Association members believe their organization is impacted by that. We can't hire our way out of this problem. Certainly as an industry, there is a zero-sum game when it comes to hiring security researchers. And that's a big problem. How can we embed security deep into the developer workflow, early on in that flow, if we just don't have the people to be engaging there? And securing our first-party software is just the start. If you're an organization that has 1 security researcher per 100 developers, unfortunately, it's not just the work of those 100 developers that you need to secure. 70% of the code in commercial applications comes from open source. That's the code that is actually executed, the stuff that's really being used. This is an analysis by Synopsys in their Open Source Security and Risk Analysis report, and they analyzed over 1,000 commercial applications to get it. We're all relying on open source, and it is the lion's share of the code that we use. So really, we need to be securing that as well as our first-party code. And you guessed it, there is no dedicated security team for the world's open source. The amount of eyes that are on that 70% number might be high because it's public, but they're not the skilled security researcher eyes that we need. The other challenge to moving security into the developer workflow is the tooling. Our security tools aren't part of the developer workflow. This is an analysis by Veracode. They're a great vendor in the static analysis space, but what this shows is the static analysis tooling that they sell is used predominantly by security teams. And let me show you why. The graph here is the percentage of, is the number of scans that are run on code bases that are using static analysis. Less than 10% of the repositories that are using static analysis are running that more than once a week. If you're not running static analysis more than once a week on that code base, there is absolutely no way that this is part of the developer workflow. This is not something that is commenting on every pull request. This is not something that is running on every commit. And in that case, it's living far away from those developers. It's living with the security teams. Why is that? Why is it that this great security tooling ends up living with security teams rather than with developers? Well, to answer that, I want to take you way back. This is a painting, and it's a painting of surgery happening in the late 1800s. The man at the back of the screen in the bow tie is a man called Joseph Lister. We'll talk about him more in a moment. But it's the two men at the front of the screen that I want to talk about first. They represent the major advances in surgery that happened in the 1800s. On the left is an anaesthetist. That person is anesthetizing the patient. That allows the surgeon to operate on them while they're unconscious. On the right is a man who is spraying an antiseptic spray over the area that, in which surgery is happening. That antiseptic spray had a huge impact on the mortality rate after surgery. Those two innovations had extremely different paths towards adoption. And I want to talk to you about what we can learn there. So, anesthesia. Anesthesia was first discovered in 1846. It was by a dentist. The man was called William Morton, and he took it to a doctor who worked in Boston, and that man was called Henry Jacob Bigelow, and said, I believe that I can knock your patients out. I can change surgery from being a swashbuckling affair where you are operating as fast as humanly possible on somebody that is tied down to the operating table and writhing in agony, screaming at the top of their lungs. And instead, you can operate on someone who is completely unresponsive. That will make your life so much easier. And Henry Jacob Bigelow said that is fantastic, and they tried it out, and it worked. And they published in a paper saying, hey, we can do this. They didn't even publish the details of how to anesthetize somebody because Morton wanted to get a patent on the gas. But Bigelow said that he smelt something that smelt a little bit like ether, and within a year, in every major city around the world, surgeons were experimenting with anesthesia. Within 7 years, it was ubiquitous in hospitals in the UK and US. The days of surgeons operating on patients writhing in agony were over, and the life of the surgeons that were performing those operations was much improved, as was the death rate. You can perform surgery much better on a patient that is immobile than one that is moving. The second story is around antiseptics. The effect of antiseptics was discovered by Joseph Lister in 1865. He was operating on a 7-year-old child who had fractured his leg in a cartwheel. And he had heard that the city of Carlisle used carbolic acid to reduce the smell of sewage, and had a theory that carbolic acid might also reduce the germs that were getting into a patient's wounds and causing infection. And just for context, half of patients that underwent surgery before this period would pass away from sepsis. Half of them. This was a huge problem. Lister performed his surgery, and 6 weeks later, when he reviewed the wounds, he found they were not infected. He carried out study after study and discovered that carbolic acid was making a big difference. So he published in The Lancet in 1865. What happened next, you might expect, would be widespread adoption of antiseptics. That reduction in death rate was incredible. That's not what happened. Lister's methods were highly divisive. Surgeons did not want to adopt them, partly because they were incredibly unpleasant for the individual that was performing surgery. Lister suggested having a man spraying carbolic acid over the area on which surgery was being performed at all times. That carbolic acid burnt the hands, it burnt the eyes of the surgeon. It created a thoroughly unpleasant environment for those that were performing the surgery, but it saved lives. Half-heartedly, Lister's methods were adopted by the mid-1880s. Surgeons began to wash their hands in carbolic acid. Very few of them adopted the process of spraying the operating theatre with that acid. Over time, momentum built towards Lister's methods, and by the 1900s, he was being widely recognized as a pioneer, and he's now considered the founding father of modern surgery. When you go into a hospital today, you normally are in an aseptic environment, one where germs are kept out in the first place. All of that progress is owed to Lister and his work on antiseptics. I tell this story because I put it to you that the DevOps space is a little like anesthesia. It makes the lives of developers and those that work on our code bases better. Those benefits accrue immediately to the folks that would choose to adopt or to not adopt. Who doesn't want tests that run quickly in the cloud and tell you whether or not your code works, rather than having a painful iteration cycle with a QA department? Who doesn't want to be able to get their code deployed as fast as possible and to be able to see it? As developers, we all tinker, as well as working on the code bases for which we are employed. And when we tinker, we want those same processes. The DevOps flow of automated testing and fast deployment has been adopted out of choice by developers in the open source community. Security is a little bit more like antiseptics. It sometimes feels like we as a security team, or those that build security products, are spraying carbolic acid over the developer population. We make a difference. It makes a big difference in terms of the security of those code bases, but it does not create a pleasant environment. It's not something that a developer wants to adopt of their own volition. We are not invited into every room. The spread of security into DevOps has been slow. DevSecOps is a slow idea. How do we change that? How do we move from having solutions that feel like spraying carbolic acid to ones that feel like they're going to create a better world, a world that developers want to adopt themselves? Well, if we're going to get there, we need to think about the developer perspective. We need to develop security tooling that is developer first. I'm going to talk to you about what I think that looks like. And I'm going to start with an example where GitHub has already done this to a pretty large extent and the effect that it had. The screen you can see on your left, vulnerability alert emails, was GitHub's first foray into security tooling. We built a database of vulnerabilities, and we started scanning the code that was on GitHub to understand what the dependencies of that code was. And when we found a vulnerability in those dependencies, we would send an email. And that email would say, hey, you have a vulnerability in one of your dependencies. You probably want to go and look at that and get it fixed. We thought that was huge. We thought that that would help secure the world's software. But what we'd really done there is automate the process that a security team member goes through. We hadn't thought about the process that a developer goes through. We were surfacing problems, not surfacing solutions. And the developer population didn't thank us for it. 2 years ago, GitHub started creating pull requests to automatically fix vulnerabilities that we found in the dependencies of a code base. They look like the screen on the right. They're very straightforward. All it does is update your dependency from a vulnerable version to a fixed version. But by creating that pull request and including the information that a developer needs, we've moved from talking about problems to talking about solutions. And we've made it 1 or 2 clicks to merge that pull request, rather than the act of pulling down your code, writing the update yourself, checking the change log, all the process to do that update. The effect is dramatic. The blue line on your screen is the percentage of alerts that have been resolved when GitHub sends a pull request to alert a vulnerability. The red line is the percentage that have been resolved when GitHub just sends an alert. At almost every time period, the blue line, that resolve rate with a pull request, is dramatically to the left of the red one. Developers are resolving vulnerabilities twice as fast in the first few weeks if there is a pull request than if there is just alert. And at every time period, we're seeing that plateau. The percentage of vulnerabilities that get fixed in any time is significantly higher when there's a pull request. A developer is much more willing to patch a project, even if it's one that they don't work on very often, if it's 2 clicks to do so, than if we say, hey, there's a problem here, but you have real work to do to figure out how to fix it. Moving our dependency alerting into pull requests is a great example of moving security deep into the developer workflow. We moved from having a setup where we were outside of that workflow. We were in emails. We were focused on problems. And we were automating the start of the journey. We were automating the work that a security team member would do to identify those problems, but we weren't automating much more. And we had a major mindset shift to one where we were at the heart of the developer workflow, where we were creating pull requests that were focused on solutions. And critically, we were automating the part of the journey that a developer goes through. And as a result, we were automating the entire journey. That's what being developer first looks like. It means thinking about what the developer needs, not just what the security team needs from the developer. And when we do it, we have a big impact. So let's think about how we can apply that developer first thinking to a bunch of other areas in security. First of all, I want to talk to you about credential scanning. Credential scanning is a really great candidate to shift left for a whole load of reasons. First of all, you saw the graph that I showed at the beginning of this presentation. Credential leaks are extremely common. At the moment, we see just around 100 GitHub tokens leaking onto GitHub public repos every single day. It's so easy to accidentally commit your .env file. It can happen to any of us. They can also be incredibly damaging. The SolarWinds attack that we saw originated in part thanks to a credential leak. The password SolarWinds123 was leaked into the public. And that's one of the ways that attackers were able to get access to those systems. Now, I'm not saying that this entire attack was due to credential leaks. Obviously, there should have been a lot more defense in depth. There were a lot of things that went wrong to cause that attack. But a credential leak was part of it. And credential leaks have been part of a lot of data breaches in the last couple of years. Credential leaks are also pretty easy to detect compared to other vulnerability types. At the end of the day, all we need to do is use a set of regular expressions with a little bit of post-processing to reduce false positives, and we can find credentials when they're in your code. This is 2021. We have the technology to do this. This is not hard. We've had the technology to do this for decades. And with credential scanning, preventing the credential from leaking at all is dramatically preferable to having to remediate it after it has leaked. When a credential has leaked, either publicly or into a private repo with a large number of readers that shouldn't have access to the infrastructure that that credential grants access to, there is a big remediation step. You need to go through and make sure that you haven't been compromised. You need to rotate that token in all the places that it's used. You need to revoke that token. If you can prevent the credential from ever making it into GitHub, you can prevent the cost of all of those steps. Just like that Poneman Institute graph at the very start showed, you can save a huge amount of time, and in some cases, the cost of a breach by preventing those credential leaks from happening at all. Brilliant. a perfect candidate to shift left. And the place that you would shift this left as a security team is into a pre-receive hook. And I have talked with so many customers that have experimented with doing that. The pre-receive hook rejects the push to GitHub before any of that information is then stored on GitHub servers. And as a result, no leak occurs. So what's the catch? The catch is false positives. This is a pretty typical looking experience. In fact, it's the one that until recently was used at Microsoft when a token is detected and is rejected in the pre-receive hook step. Let's talk about why that's a problem. When we move credential scanning into the developer workflow, we make developers responsible for triaging the findings. And developers aren't going to triage those findings in the same way that a security team would. A security team looking at a noisy pattern, which is finding credentials, will have a single screen where they can look at 100 results. They'll eyeball a bunch of them, they'll pick the one that looks realistic, and they'll throw out the other 99. It won't take much time. It's done in bulk. That's not the experience that you live with as an engineer when your push gets rejected. A noisy pattern now means that 99 times out of 100, when you push and it is rejected, you have to manually override. That's gone from being an experience where rejecting those false positives is trivial to one where rejecting each one has a high cost in terms of your time and energy. There's always an escape hatch. There has to be an escape hatch when it comes to pre-receive hook scanning. There are cases when we just can't afford to block any push. Perhaps we're dealing with a live incident. Perhaps for some reason this pattern is so noisy that there are legitimate reasons that we would need to push strings that match it. Combination of the above means the solution gets rejected over and over again by developers. And that's what happened at Microsoft with some of this pre-receive hook scanning. That's what's happened with a number of our enterprise customers who have played with rolling their own credential scanning solution and putting it into pre-receive hooks. The solution gets rejected. At Microsoft, we saw 50% of the times that a pre-receive hook rejected a push being overridden. 50%, a 50% false positive rate. And 3% of developers were so irritated by this, it appears that they scripted the push process so it would always override. That's what happens when you try and push these security solutions into the developer workflow without thinking about what it is that developers need. So what if we design the experience around the developer instead? What if we're building for them as well as the security team? What would that mean for the solution that we create? Well, first of all, we'd want a much better triage experience. We wouldn't be pushing tokens that have a high false positive rate into pre-receive hooks because it's just not appropriate to triage those one by one. And when we do need to triage them, I would want, as a developer, all of that information in the command line as the push is rejected, so that I can triage it from the command line, no context switching, no need to find that in my editor. If it's a false positive, I want a 1 or 2 command way to override that straightforwardly. What about the results that have too high a false positive rate to move into a pre-receive hook? Well, we can think about a defense in depth solution here. If you can't get something into a pre-receive hook because the false positive rate on the pattern is too high, perhaps we can do something else. When we've actually pushed that to GitHub, we have a bit more time. You need to do a pre-receive hook in, well, at the very least in under 5 seconds, but really you want to be doing it within a second. Otherwise, you're increasing a significant lag on every push that your developers make. When you've already pushed, you have all the time in the world to scan that code and understand whether or not there are real secrets in it. And one of the things you can do is call out to the partners themselves. Say, oh, okay, I think that this credential might be an Azure DevOps credential. Let's hit the endpoint. Let's find out and verify whether it really is. And then if it is, we could raise that information at pull request time. It's not as good as stopping it before it ever makes it into your code base. Absolutely not. But for a lot of credentials where developers introduced it because they then want to use it in their service and they believe that committing it to the code is a sensible way to do that, it's pretty good because that credential isn't being used in production yet. And that means that we have time. We can go and revoke that credential without having to worry about doing a zero downtime process in terms of rotating it. So we'd move the high false positive scans into another forum. But why scan at commit time? I know that's what we started out here, but why not whilst I'm coding? Really, I've already got a context switch if I have to say git push and then read an output that says, no, that was rejected. I want to hear about any credentials that I might be writing into my code at the time that I'm coding. We could embed this into the editor experience. If you're using code spaces, there's no reason why we couldn't be asking GitHub whether or not this looks like a false positive. And if we're in the editor, we have far more options around the interface for dealing with these. We can make it just a 2-click process to say, no, this isn't a secret, mark it as a false positive, and let it through when I push. Or we can give the information, detailed information about how it is that you should be working with those secrets. It feels like this belongs in the editor. And if it's in the editor, then we can be doing some of that stuff about validating whether or not this is a real token, even for our high false positive rate patterns. But let's take a moment to think about those high false positive rate patterns, right? They're causing us a lot of problems. Is there something that we could do there to just eliminate them? Given how expensive they are once we're pushing credential scanning into the developer experience, maybe we could move the whole industry forward on false positives. At the end of the day, they're caused by token patterns that are hard to detect. What if we went out to all of those token issuers and said, hey, perhaps you could change your token pattern. Perhaps you could make it easier for us to find in credential scanning. And as a result, reduce the number of times that your credential is ever leaked and the number of times that you, as a service provider, ever have to worry about fraud on my account. Our service providers are just as aligned with us about that security. GitHub is doing exactly that, actually. The GitHub personal access tokens that we issue right now are difficult to detect. They are base 16 40-character strings, which collide exactly with commit shards. That's a nightmare. It's almost impossible to programmatically detect those. We can do it as GitHub because we can compare them with the hash of the actual personal access tokens that we have stored in our database, but nobody else can do it, and that's no good. So last week, we announced that we're making a change. We're going to keep those as 40-character strings, but we're going to start prefixing them. We're going to change the character set from being base 16 to being full alphanumeric. We're going to add a check digit to them, which means it's possible to validate programmatically whether they're real in a very straightforward way. We're going to go from having tokens that were undetectable or impossible to detect without a 99% false positive rate to ones that are really best in class. And then we're going to ask the rest of the industry to do the same thing. Some folks are already way ahead here. Some token issuers issue their tokens with fantastic patterns, but some don't. And we believe that as an industry, we can get better. And by doing it, we can move credential scanning into the developer workflow. We can eliminate this problem. But there's a lot of work there. There's a lot of thinking that needs to go into how you make the developer experience here excellent. And there's a lot of change that we need, not just in our security teams, but across the whole of the industry. Okay, another example. Let's talk about static analysis. If you're an engineer, and I know 50% of the folks that have dialed into this call are, then you may not know too much about static analysis. I didn't. I was an engineer until 3 years ago. I was full-time writing code, and I'd never really encountered static analysis. If you're in that camp, then static analysis you can think of as a supercharged linter. Linters tend to scan file by file, looking for problems. Static analysis looks a bit deeper. It looks across an entire code base, but fundamentally it's doing the same thing, except it's focused on vulnerable patterns. So it's trying to find places where code might flow from a source of data that an attacker could inject data into, right through to a place where it's used in a way that could cause a vulnerability. So think SQL injection. The data might come in through a query string, pass through your application unsanitized, and then get used in a database call that doesn't apply sanitization. That's a vulnerability. That would be a SQL injection or a NoSQL injection vulnerability. Static analysis can find that. That's the kind of pattern that it's looking for. The trouble is that static analysis tends to be pretty noisy. It often produces thousands of results. And as a result, those results almost always live with the security team. That's the graph that I showed you earlier from Veracode, saying that fewer than 10% of repos that are using static analysis at all, and let's not forget the majority of repositories don't use any static analysis, fewer than 10% of those are scanning more than once a week. They are not scanning every commit. They are not surfacing that information in the pull request. What should static analysis look like? How do we move this out of the hands of security teams and into the developer workflow? Well, again, there's a lot of work to do. Again, we need to be thinking at each step of the way what the developer experience is. But fundamentally, static analysis should feel like code review by a security expert. That's the promise of this technology. The idea is that you would have an experience that's just like having a security team member review every single one of your pull requests, except that security team member would have infinite time. And their ability to really go into the detail and help you on any of these would be incredibly high as a result, because the entire process is automated. The results should be surfaced in your pull requests. They should have excellent help text. If we're going to move static analysis into code review, if we're going to have it at pull request time, then it needs to be as good as a human would be at reviewing your code. When somebody reviews my code, I expect them to provide relevant and accurate insights in the feedback that they give me. I don't expect them to be wrong in their suggestions more than, say, 10% of the time. And in fact, Google did a lot of analysis about what it takes to move static analysis into code review. In between 2008 and 2010, they were working with a tool called Spot Bugs on their Java code. And they started out with spot bugs in a place that I would say was far outside of the developer workflow. There was a spot bugs dashboard, and that is where developers could go see information about the stock of vulnerabilities in their code. What happened? Nobody went, because it wasn't in the developer workflow, because developers didn't feel like it was their problem. They decided, okay, well, let's start cutting issues for each of those bugs that spot bugs find. And they moved to that model. And what happened? Well, developers reviewed a bunch of those issues, but they only fixed 14% of them, because a lot of the issues weren't relevant. They were things that were real, but they were linting style problems that developers didn't feel like were pertinent, not things that they really needed to fix. And then they moved static analysis into the pull request. And what happened there was that some rules were incredibly useful, but the noisy few rules that had a high false positive rate ended up in a kind of organ rejection scenario where developers would tear out the entire solution because they became inured to those comments because there were so many false positives. The golden number that they ended up with in terms of false positive rate was that it should be below 10%. That means a 90% fix rate. We need, if we're going to move static analysis into the code review process, it to be highly accurate, produce highly relevant results. That's not impossible. It's not beyond the technology that we have in 2021. A great experience would also include suggestions, right? It's not just about calling out problems. Like you saw with the dependency work I showed earlier, really you start to get even better engagement when you can suggest exactly what the required fix is. And for simple problems, this, again, is not beyond us. Sometimes it's hard. I don't want to pretend to you like, much of this stuff is easy, but in some cases, we can already get to a point where we should be able to include suggestions. But here's the really killer feature of moving static analysis into the security review. The quality of the static analysis that's getting applied should aggregate all of the world's security efforts. Static analysis is, at the end of the day, a bunch of rules that are encoded programmatically and then can scan every single change that is being made. We can iterate on those rules. We can make them better day after day. And as we iterate on them, we don't just have to have our own expertise building them. Because when you're thinking about how to detect SQL vulnerabilities, you're thinking about the same thing as every security team around the world. Because we all have that problem. None of that is specific to our business. And we need a way to collaborate on those problems. Static analysis can provide the platform for that collaboration. What if every security team was contributing to the same shared rule set? What if we were together refining each of these queries to reduce its false positive rate, to reduce its false negative rate, to make it the best that it possibly could be? What if when a security researcher at Google or at Microsoft thought of a new novel attack vector and wrote a rule to find any instances of that problem, that rule got applied to every open source code base, to the code base of anybody that's using that static analysis software? That's the promise of static analysis. that you can have a review on your pull request that leverages all of the world's security knowledge. That review ought to be able to be truly fantastic. We're building this at GitHub. If you go to github.com/feature/security, you can find out more. The static analysis engine that we're building it on is CodeQL. All the rules for that are open source. There's a lot of stuff that I've talked about today that is around our vision. And our vision is to move security into the developer workflow, and it always will be. Everything that GitHub builds around security is going to be developer focused because we are a developer first company. We haven't solved all of these problems just yet, but this is where we're going, and we want you on that journey with us. I want to leave you with some closing thoughts. First of all, if we build for developers, we can shift left. We need to think about them in the tooling that we build to move out of this world where our scanning technology lives with security teams and move into a world where it lives with developers. It's hard. It requires thinking about what developers need as well as what security teams need. It requires some delicate balances, but it can be done. And when we do it, it makes a difference. If we can work together, we can do more. We're hopelessly outnumbered. And it is a zero-sum game trying to hire more security researchers. The industry cannot win, and we will be in that position for some time. But if we can build a setup where the security research done at one company accrues to all companies, we can start to turn that on its head. We can build a corpus of security knowledge that then applies everywhere and overcomes the difficulty of that ratio. If we do both of those things, if we build tools that developers love and work together, and those tools encode all of our information, then we can secure the world's open source. Developers will choose to run great tools on the work that they do outside of work. And if those tools encode all of the information of the security team that they have at work and all the information of all of the world's security researchers, then we can truly secure open source code. GitHub will always give everything that it built in this space away for free to all open source repositories. DevSecOps is a slow idea. There's a huge amount of work required here. There's a reason that it has taken a decade to move security into the developer workflow, and it won't happen overnight. But slow ideas can change the world. They already have. When you go into any hospital, the entire setup is based upon that work of Joseph Lister. I believe that the work we're doing now in terms of moving security into the DevOps lifecycle is the same. It will be the foundation of security for the future. Thank you so much. I'm going to invite Sean back and we're going to answer some questions. I'm really looking forward to talking to you more about what you've seen today.
Hey, Gray, that was pretty incredible. And I got to tell you, I love that analogy. And as you can see in the chat window, other folks loved it as well. Looking forward to having some one-on-one time with you to kind of learn how to pitch that analogy in any future conversations that I have. So awesome job. Awesome job. And as you can see in the chat, it looks like everyone else feels the same. So great. It looks like we've got some questions for you. So I'll start off with the first one here, and it looks like it's from Andy Fox, and Andy's question is, what strategies would you recommend to make developers more security aware to bridge the gap?
Gosh, yeah, it's a really good question. And again, for me, it comes back to tooling that embeds that security awareness in the developer workflow. The times when developers are going to be most receptive to information about security is when they are presented with a security incident. And there are a bunch of moments when if we can provide that information, we will be providing it to a really receptive audience. Any static analysis result that we're surfacing on a pull request, for example, should come with detailed information about that vulnerability. It's all very well to say, hey, you might have a NoSQL injection vulnerability here. But if a developer doesn't really understand what NoSQL injection is, you want something that they can click out to exactly in that moment to find out details of exactly that. So I think embedding that text deep into the tooling and into the developer workflow so that help is delivered at the moment that it's needed and that we as engineers are going to be most responsive to it is the way forward.
Excellent. Thanks, Greg. Next question from Kevin Markley. Will this integrate with GitHub Actions? Kevin, when you say this, I'm assuming you mean code scanning.
Yes, it will. So static analysis needs a platform to run on. At the end of the day, you're doing some quite deep program analysis, and you need what is essentially an isolated compute environment in order to be able to do that. You may well be tracing the build of an application, and that requires essentially detonating that code. So you need an isolated environment, and Actions provides exactly that. So do other CI environments, and the solution that GitHub has built here with CodeQL and with code scanning works just as well on Jenkins as it works on Actions. But on Actions, of course, we can embed it deep into the GitHub product and make it incredibly easy to set up.
That's a good question. Good answer. So there's also one here from Grace. This is a good one. So Grace's question is, we'll always have more than one scanning tool in our company. How do we integrate them all? And it looks like Nathan, thanks for that answer. It looks like Nathan tried to answer it, Gray, by talking about Seraph integration. Can you talk a little bit more about that?
Yeah, absolutely. I think this is a really great question. And I think I didn't say this in the talk, but it's exactly the right premise to have more than one security solution. Security is about defense in depth. Static analysis will get you some of the way. Credential scanning will get you some of the way. But you're going to want other solutions in there as well. You're going to want dynamic analysis. You may want IAST. You may want a host of other things. You're certainly going to want a bug bounty program. You're certainly going to want to do penetration tests as well. How do you integrate them all? You really want to display a consistent interface to developers, and you really want to have a consistent way as a security team of working with the alerts that come from any of them. And we see our role as GitHub to provide those interfaces. Anything that GitHub builds, we're really passionate about creating an open platform. So when we've moved into the static analysis world, what we've done with code scanning is open up the interface that we show to developers to any static analysis tool. Any of those tools can output SARIF, the static analysis results interchange format, which is it's an OASIS standard. It's not something that is owned by GitHub. And if you create that SARIF, you can upload it to code scanning, and then the results from any static analysis engine really can be displayed in the pull request in an identical way to the way that CodeQL results are displayed. So developers don't need to learn a dozen tools. They just need to learn one.
Thanks, Greg. All right, another question. There's actually a ton of questions, guys, and we're going to try to get to all of them. I'm just randomly going down the list that we have here today. So another one that I see here is devs want low false positives while security teams, want to avoid false negatives by all means. Static analysis is always a trade-off. How would you balance it?
Yes, gosh, it's a good question. So, I have two answers to that. The first is, yes, it's a trade-off, but we can get better at both. We can improve the technology that does those scans. We can improve the rules that are doing those scans in order to reduce our false negative and false positive rates. We can get higher precision and recall, to put it in the technical parlance, by improving those queries. So it's not always a trade-off, and we as a tooling industry need to get better at delivering rule sets that deliver great results for both security teams and developers on those two axes. And we can do that if we're all working together on it, if we're iterating the queries together so that they're constantly being refined to weed out those false positives without losing false negatives. That said, at any given time, absent those improvements in technology, there is a sliding scale. How many false negatives do you want? How many false positives are you willing to tolerate? That question you need to answer depending on the context of where you're surfacing those results. As a security team member, you might be happy to wade through quite a lot of false negatives to try and one true positive. As a developer, you don't want those false negatives in every one of your pull requests. So when you're surfacing things in the developer workflow, they need to have a low false negative rate. As a security team member, you might want to run those queries at a slightly different setting or slightly different, more experimental queries, and you can tolerate a different false negative percentage. So it depends on the context where you're doing the scan, but don't forget that we can get better at both of these by improving our technology.
Thanks, Gray. Thanks, Gray. Let's see, we've got some more questions here. Oh, this is an interesting one. Are there languages that are excluded from SCA, specifically older languages like Erlang?
Interesting question. So software composition analysis, which is what SCA stands for, software composition analysis, it fundamentally is about understanding the dependencies that you have, understanding the code that you're actually running, and then layering on top of that metadata about those dependencies. One thing might be whether or not there are vulnerabilities in those dependencies. Another one might be the licensing information. Or maybe it's the security posture, or it's who the maintainers are. There are a number of different policies you might lay on top. Any language that has dependencies should have the concept of software composition analysis. You still want to apply those rules. Now, in terms of GitHub's offering, we focused on the languages that are most popular on GitHub, and we'll continue to do that. We are always working on expanding the number of languages that we cover across all of our tools. But that concept of software composition analysis, I think that applies anywhere where you have an open source ecosystem.
Great. So it looks like we have time for one more question. And this one says, do the latest static analysis tools help give a sense of risk or priority to dev teams?
That's a really good question, and it's a tough one to end on. In the security world, we try to be really precise with the terms that we use. So you've said risk and priority, and those are tricky things in order to give an idea of. If you'd said severity, I would have said yes. We have industry standards for defining what severity means. It's, strictly defined as meaning essentially what is the worst case that can happen if this vulnerability is real. Is it that customer data would be leaked? That would be an extremely severe condition. Or is it a denial of service? That's still pretty bad, but it's not as bad as a data breach. So that would be severity. Risk and priority, they're harder. So they're around a combination of likelihood. So how likely is this result to be real? And yes, a good static analysis tool will tell you that. Severity, which I just talked about, and yes, a good static analysis tool will tell you that. But they're also about context. They're about whether or not this repository is an internal-facing tool or whether it is your main customer backend. Your priority is going to depend on that. And that's not something that static analysis or any other security tool can easily detect automatically. That's where we need to layer on human information. And building tooling that makes it easy to combine that human information that allows us to generate those priority and risk scores is something that I think GitHub is really interested in doing over the longer term.
That's awesome. Thanks, Gray. So let's see. Looks like we're coming towards the end of time. Hey guys, I want to thank you all for joining today. Gray, as always, awesome presentation. So
my pleasure. Thank you so much for hosting, Sean.
Yep, thank you. So yep, I'm gonna let's see here. Here we go. So as you can see, today was the first day of Security Week at InFocus. We've got a pretty exciting week here. We've got 3 more days to go. So tomorrow we're going to actually have a one-on-one fireside chat with the folks over at Eli Lilly, where we'll learn about what a developer-first approach to application looks like in practice. And then on Thursday, we're going to have an interactive roundtable style discussion on going from DevOps to DevSecOps. And on Friday, we're going to have a tactical deep dive and demo on GitHub Advanced Security. So before we wrap up, folks, don't forget, our team is available to chat with you about anything that we've covered today. So please don't forget to click the book a meeting button on the right side of your screen. There's also a QR code that you can scan here if you want to take and book some time with us, after these meetings. Let's see. There's also a survey. Actually, I made a little mistake there. That QR code is actually for the survey. So please feel free to click that QR code for our survey. And you can also answer that survey in the Docs tab on the top right-hand corner as well. So once again, thanks again for joining us, and we look forward to seeing you again tomorrow. Thanks, everyone.